Well, good morning, good evening. Welcome to AI Foundations. We are starting the first session in Module 2. And so we're going to start sort of diving deeper into some of the topics we covered in Module 1 and really trying to demystify artificial intelligence. And so some of that is just uh, trying to explain a little bit more how it actually works. So with that, I'm going to hand it over to Shamir and let her get started.
All right, just checking. You can still hear me, right?
Yep.
Okay, good. All right, so hi everyone, and welcome back. This is Module 2 and the first session in Module 2. So, today we're going to discuss some of the components and applications of AI in a little bit further detail. All right, so what you can expect today. Here's the agenda. So we're going to do a little bit of an introduction. We'll talk about some AI building blocks, and then we'll also talk about some common approaches and applications of AI today, and then summarize with how AI systems work. And then we'll talk about what's next. This is just a reminder that this is the session that you're in. And, as we go along, I'll continue to kind of, or, we'll continue to kind of just guide you to make sure you're in the right place. But this module does consist of 2 sessions and then a study group and an Ask Me Anything forum. And then we'll be moving on to machine learning foundations next week. And of course, if you want to see the full schedule, you can always go to the training site. All right. I wanted to just send out a quick reminder here about what we're going to talk about today. So this AI Foundations course is just introducing you to key concepts. So, there might be learners from all different backgrounds and experience levels. So the intent here really is just to provide some basic knowledge. So that if you decide to only complete the AI Foundations course, you'll have, a greater understanding of how the use of AI is important within organizations, but if you continue on to the machine learning foundations course, you'll have a greater understanding of the basics before we get into the coding parts. So just as a reminder, each week or in each session as we're going along, we're peeling back the layers. So the material is going to be covered methodically. And, just another note that, if you happen to see this little cloud thingy here, I will try to note where we'll dive deeper in later sessions for you. All right, so now we're going to talk about the AI building blocks. So let's review what is AI again. Last week we introduced you to a widely accepted definition of AI, and this week I'm going to try to simplify that for you a little bit further. So AI really consists of a set of technologies that enables a machine to perform tasks that were thought to require human intelligence through a number of different applications. What makes AI useful is that it's really efficient and it's systematic, and it enables it enables a machine to take large amounts of information and extract insights from it. So if you think about that, once you kind of get past all of the like fancy and really interesting terms, AI can utilizes a set of software that uses a set of rules and or math to help find patterns in the data. So just a moment ago, I said that AI helps machines perform tasks that were, thought to require human intelligence. So here I want to just briefly talk about what some of those tasks are and how to categorize them. So the first one is perception. And this is where a machine can perceive the world by taking in information and processing it. And so that information could be things like text or images or sound or videos or other types of information. But it's all about, being able to take that data and then process it. Humans are really, really good at pattern recognition. And, when and a machine can actually use artificial intelligence to find patterns well, too, through data, just like humans can. The next thing that, the next way that AI helps machines is through being able to take certain actions based on the patterns that the machine recognizes using AI. And then one of the last major ways that AI kind of helps machines when we talk about human intelligence tasks is by learning. And that's where the machine can use AI to help optimize. And you'll hear that word, often as we continue talking, but to optimize the machine's performance based on feedback or learnings from past outcomes. So that can include failures or successes, and this should happen on a continuous basis. So if you've recognized anything, it's that most of the ways in which AI helps machines are in tasks that can be performed by humans, but it's usually faster and there's much more volume involved. All right. So we're going to go back to this diagram again, to talk about AI and some of the different subfields within it. So I'll talk about a few here, and then we'll talk about the major ones in a little bit further. But if you'll note here, we will talk about them in more detail in modules 3 and 4, and definitely when we get to the machine learning foundations course, we'll talk about the application of some of these techniques. Um, so um, So a lot of work done today across many different industries is done with machine learning. Like we said that last week, but it's not the only way for a machine to learn and decide and, take action. So over the next couple of weeks, you're going to hear more about, machine learning and reinforcement learning and deep learning and natural language processing, or NLP, and computer vision. But today I'm just going to start with a simple overview of many of these bubbles that you see over here. And, just note that over time, just like these, certain subfields within a subfield have kind of gained some sort of definition, there may be further, discoveries in the future where, you might see another bubble that overlaps some of these minor bubbles, dedicated to specific applications of AI. So this diagram here doesn't represent all of the other ways artificial intelligence can enable a machine to perform those tasks, but these are major ones that are used today. So, I'll just point out a couple that I'm not planning to spend much time on at all, but we can definitely provide you some further material if that's something of interest to you. But so grammars, for instance, they're mathematical models that help derive rules for natural language conversation. Those were created back in the 1950s. A knowledge graph system, they're useful in AI when we're talking about communicating context. And you can see that they're within this NLP bubble here. So they help to represent data and its meaning, and using things like semantics or other relationships to get a contextual understanding that can help a machine make a decision. So I would just say, if you have any other questions about grammars or knowledge graph systems, then either bring them to the Ask Me Anything, or we can provide some resources after the fact. All right. Let's see. Let me go ahead and just answer this question here. So, should I consider ML a subset of AI? And deep learning, reinforcement learning, computer vision, robotics are a subset of machine learning. If you look at this if you look at this image, then yes, but there are lots of them are interconnected. So machine learning is definitely in the hierarchy of artificial intelligence. It is definitely one of the major ones, if you look at the size of this bubble. And so deep learning is definitely within this machine learning family. So is reinforcement learning, but there are some overlaps between reinforcement and deep learning. And then robotics kind of can deal, you can use machine learning and NLP depending on the task specifically. So you'll probably find a lot of different information about some of these technologies out there, but it's useful to kind of remember that an intelligent system is usually comprised of many different techniques. So you can take a machine learning technique and a specific NLP technique. You can maybe use an expert system with machine learning to get to actually solve the problem that you're looking for, depending on the complexity. I think I saw a question that said that asked what NLP stood for. That's natural language processing. Okay. All right. So let's talk about data. And I can't stress this enough. and we'll say this probably again and again. But in future sessions, there's not a whole lot of attention on the history of some of this types of data. So I just want to spend a little bit of time here talking about it. And we'll talk about two major types of data. These aren't the only ones, but these are the major ones that you'll probably come across in your learnings and your journey. And they're heavily prevalent today. So the first one is structured data. So structured data is any data that you can kind of house in some sort of fixed field, like in a record or a file. So if you've used Excel, think of a spreadsheet or a relational database. That's structured data. It's easy to collect. And it's easy to enter, it's easy to store, to query, to analyze, but you might have some restrictions on that data, like is it numeric? Is it textual? Is it a name? Is it a date? Is it an address? And then sometimes the input itself can, have a little bit, some restrictions like the length or the number of characters, making sure that each observation kind of fits in a specific category. So structured data, on the other hand, we've got unstructured data, which is the information that either doesn't have some sort of like definition or is not organized in a, really defined way, in a predefined way, maybe that's a better way to say it. So in structured data might include things like text or, some other multimedia content, definitely emails, like documents, like Word documents or videos or photos, audio, web pages, lots of business documents. Those are types of unstructured data. And this type of data is growing very rapidly. And there's a lot of information within organizations that is indeed unstructured. So, I think one of the competitive advantages for organizations is to be able to harness this unstructured data. And so that's where a lot of these other specialized types of subfields of artificial intelligence come into play, is being able to handle this unstructured data. So let's talk a little bit about some examples in a little bit greater detail. So structured data can consist of things like census data. So, what's the birth date, your income, employment, et cetera, like place of birth. There might be some economic data that you might pull in. If you use Facebook, like the like button might be something that could be considered structured data. If you've got a purchase history or billing records, sometimes certain aspects of CRMs have structured data. There's definitely machine generated structured data. So when we talk about sensors, like there's RFID tags or radio frequency ID tags, medical devices, there's GPS data. That's data that is structured, but it's generated by a machine. And you'll see a lot of that, when we talk about maybe like logistics or supply chain or inventory control. There's also point of sale data that, could be machine generated and structured. So, what time did the purchase occur? What was bought using a barcode, and all that other information that can be easily organized in a structured way. this unstructured data. So when we talk about unstructured data, and hopefully this will answer the question here about why structured data makes up less of the data in an organization than unstructured. There are many different unstructured data sources. So, when we talk about, just think about, your life as you work, or, if you're in school as you're doing your studies. There's so many different ways to capture information. So if you're writing a paper, you're using maybe a Word document or a Google Doc. If you're doing presentations, those are all considered like unstructured data. If you're writing email, that's unstructured. If you use social media, your posts or images, that could be unstructured. If you look on YouTube, or maybe use Instagram, or some other website, that's unstructured data. If you leave a product review, that could be considered unstructured. Definitely customer complaints. Let's see, if you call into a call center, that audio file can be used to either improve service or answer specific questions that a customer might have. Definitely like annual reports and SEC filings, those are all considered unstructured data. So that this information is a lot more voluminous than the structured data. And one of the reasons that but it's harder to manage. It's hard, it's more expensive and harder to store. But because you can think about, like, this comes in all different formats and files, all different formats and sizes. Whereas structured data, you do have more restrictions on that kind of data. I mentioned before that there's machine generated data that's structured. There's also machine generated data that is unstructured. So, just to give you a couple of examples, maybe you've got like satellite images. So those are, unstructured. Maybe you're using radar or sonar data, excuse me. So like there's both machine and human generated structured and unstructured data. The one thing that I want to just say before I leave this here is that there is new data that is generated every day, and there are new uses for it being found. And so these are not the only types of data that exist, and sometimes data can be structured and unstructured. But what I really wanted to just point out is, like, there are major types of data that exist, and you should be able to recognize when something might be structured and when something might be unstructured. Does someone want to make a comment?
Yeah, Chemere, I just was going to ask, add to this is the other thing as you think about, artificial intelligence and maybe the problem you're trying to solve is, as you kind of think, okay, what data sets do you have available to yourself? They're structured and unstructured, and some of the data is going to be within your enterprise, right? That, it's being generated by you, and some of the data is outside of your enterprise. Like if you look at structured data, census data is outside of your enterprise that you can leverage to enrich your particular analysis, maybe of your customers or or you're trying to sell. Or now, if you look at the situation, there's lots of data generated by COVID, and a lot of that data is public data. So as you think about your what you're trying to do, think of the data, whether it's structured or unstructured, or inside or outside of your enterprise, and all of the data that you can leverage to make a potential decision.
Thanks, Raphael. All right, so now we're going to talk about some of the other AI subfields that are really popular. So here we're going to look at just a breakdown of some of the larger AI concepts and like their applications. So here we have, we'll talk about machine learning and deep learning in just a second, so I'm not going to put a lot of emphasis here. But actually, machine learning and deep learning can tackle some of the same types of tasks using different methods. So I'll talk about that in just a moment. But here, artificial intelligence can also be used for planning, scheduling, and optimization. Remember, I said we were going to talk about the word optimize a lot, or frequently. So, when we talk about planning, scheduling, and optimization, um, a machine that uses planning is actually looking to see, what steps to take. And then the scheduling piece means when to carry out those steps in order to achieve a goal. So like you've got like pretty much three main portions of this planning process. So you want to identify what's the initial state, what is my goal, and then what are the actions within a specific domain that need to be taken. And so this helps to tell the machine what to do using the AI. And so when we talk about optimization, this is really the process where a machine kind of finds the most optimal way to make all of the necessary adjustments or calculations using all of the data it has to increase the probability that its guess, or in this case, that the prediction is as close as possible to reality, and that getting it close to the goal state in the most efficient manner. So we'll talk more about optimization definitely in the machine learning foundations series, where we'll talk about specific techniques used to do optimization. But I just wanted to point that out, that that's something that happens within lots of these different tasks that are using machine learning, or excuse me, that are using some AI concept. But just wanted to point that out. Any further questions, we can talk about that later. I'll point out computer vision here. We'll talk about this additionally in a few minutes, but computer vision is used to help a machine kind of take images and extract information from it, analyze it, and then interpret them, or videos, not just images. And so this is done usually by taking that image or video and converting it into some sort of numerical array, and then allowing either a machine learning or deep learning algorithm to make predictions on that input. So without getting too much more into detail, computer vision is used in applications like self-driving cars, or if you're familiar with the Amazon Go retail concept, you can go in, they'll use computer vision, you go in, you pick up products, and then, when you leave, your account is charged for the things that you kind of took with you. That's oversimplifying what's happening, but you get the point here. But there are a number of different, techniques that can be used when we talk about computer vision. And, because we've got efficient algorithms like deep learning, and, we've got better ways to compute like GPUs. And, we've got much more training data. So like Raphael mentioned before, we've got data that is coming from all sorts of places, whether it's within an organization or outside an organization. And computer vision can take advantage of that increased abundance of information to provide better results or to improve. So some of the other ways that computer vision might be used are in like text recognition or handwriting detection, facial or object recognition, OCR, which stands for optical character recognition, which, just to sum it up real quick, which allows text to be recognized within an image. So you'll hear more about some of these computer vision applications in the deep learning section, but I just wanted to point that out here. We'll skip over here to speech processing. And, I'm pointing these out just to make sure that you understand, like a lot of these are being used in products that you probably are already familiar with. But speech processing is the ability for a machine to convert words or phrases into something a machine can read or, use. So this uses natural speech. So it is related to natural language processing. And there's a number of different methods that are being used. So speaker identification. So if you use a voice-based assistant, speaker identification and verification are used for that sometimes. Or if you call into a call center, they use a technology called IVR usually, which stands for interactive voice response, where you might call and be asked to repeat certain lines, or like connect my call for support, or etc. So in this way, your voice is being recorded, and it can be analyzed to make sure that it's you that's calling, especially if maybe you're calling a bank or something about your account. That's really important to make sure that you are who you say you are. Um, and so there are a number of different other applications of speech processing in use. So if you use hands-free calling when you're driving, you can just say, hey, call home. Or if you use text to talk function, then that's an example of speech processing. The last one I'll just point out really quickly here, only because I think it's really cool, is robotics. And at a high level, this deals with how to create and operate robots, or a robot that can help solve some human tasks. So this field is still evolving, and there are a number of companies that are doing some interesting things. So maybe you've seen the Boston Dynamics kind of humanoid robot. They're focused on things like human simulated movement. Amazon is, working in the robotic space. They are heavily invested in, robotic technology that helps with logistics. You can imagine moving that many products requires some additional help outside of human help. So we won't cover robotics in, this course in any further detail, but I did want to point out because that was one of the bubbles on the image that we saw earlier. All right, so let's get into some things that you will hear about in the next couple of sections here. So machine learning, we know that it's really important for a large number of tasks that, are undertaken by organizations today, especially when we talk about like automated decision making and things that we integrate, or systems that are integrated into products and services. So there's a number of different ways that a machine can actually learn. And they're grouped into, different families of algorithms. So one is supervised learning. So that's where data is organized and, described using features, and it's labeled with the correct answer. So you give the machine the right answer. And it's presented to the machine, which then learns to recognize features on new data to be able to predict the whatever the outcome is. So essentially, a machine is being taught by giving it examples to learn from. So if I were trying to get a computer to tell me whether or not my row of data was an apple, I need to provide it features that help describe that apple, and then give it examples of rows of data where the features do describe an apple to find that apple pattern. So maybe I could talk about things like the color, the size, the shape. I don't know, just other things about apples that would be important in saying this is an apple. But I want to, just note that predicting whether something is one thing or another is not the only application of supervised learning. There's a number of different tasks that you can do with supervised learning, like detecting fraud, or identifying spam in email, or be used to forecast things like weather or stock prices or the total number of sales and so on. But it's also important to note here that deep learning, which is a subfield of machine learning, if you recall back to that image that we showed just a little bit earlier, and it uses artificial neural networks in different layers, in successive layers maybe, to solve problems using large amounts of data, can still be used to perform supervised learning tasks. So you'll see that in modules 3 and 4. Just with machine learning and deep learning. And then hopefully you'll be able to kind of see what the benefits of one are versus, or when that it's a better application to use maybe a deep learning than it would be to use machine learning for certain tasks. Okay, so when we talk about unsupervised learning tasks, we are giving the machine unlabeled data. So we're not giving it examples, labeled examples. And the algorithms in this family are going to look for patterns or anomalies, and then be able to um, create categories or groupings of the examples. That's just a really oversimplified way to explain it. So in this example, we're giving the machine a number of different um, rows of customers which have certain characteristics, and then they're sorted into one group or another. It could be multiple groups, but just for simplicity's sake, they're they are characterized into group A or group B. And so this is done without telling the computer explicitly which group to put them in. So aside from like maybe clustering or customer segmentation, you can use unsupervised learning to do targeted marketing or make product recommendations. Or even in the healthcare space, maybe you take large amounts of data about a specific disease to figure out, what are the patterns of the symptoms, and then be able to match that to the outcomes of, the patients. So sometimes like getting this type of information would take a really long time to label, and there might be a benefit to being able to just look to see what are those patterns within these patients and the symptoms, and then come up with some sort of approach to help determine the outcomes more quickly than maybe using a supervised learning approach. So here, deep learning is also really good for unsupervised learning. All right, and then the last major group of machine learning algorithms are related to reinforcement learning, and that's really just a behavioral learning model. So the algorithm basically just receives feedback from the uh, the analysis of the data, so that in the end the user is able to take the best outcome. So in reinforcement learning, the machine also is not trained with the sample data, isn't trained with the example or the sample data set. It actually learns through trial and error. So if you think about, making a successive number of successful decisions, will allow you to will allow the process actually to be reinforced, because it helps to solve the problem at hand. So, just to give you some examples of reinforcement learning, it might be used in robotics or game playing, self-driving cars, um, or, to make this even more relatable, um, think about what happens when you train a dog to take some action, based on rewards. So if a dog gets a treat every time you tell him to sit on command, then he'll, more than likely take that action the next time to get the treat. All right. So the next major area of AI we'll talk about is natural language processing, which or NLP, which enables a machine to understand human language in a number of different ways. So, I will say that it's important to note that a machine is really not capable of handling nuance very well, but it does do well on tasks like translation or text translation, or being able to summarize content. So, and it also works really well on written or spoken natural language. So there are really two basic concepts of NLP. One is natural language understanding, or NLU, and the other is natural language generation, which is NLG. So, and just one thing to just kind of like think about, if you've interacted with a chat bot or some sort of voice assistant, then then those are like commonly used for NLU, and NLG are commonly used for those types of purposes. So, to give you just a little bit of insight into what NLU is, which is the harder of the two tasks, NLU takes human speech and then it breaks it down into like useful representations in the form of a feature vector. And you'll hear more about that in the Module 4 and the ML Foundations. You'll be able to apply that. That can help the machine recognize things like sentiment and intent, which is really helpful when we talk about understanding text or speech. So NLU can also look for meaning, and may even use other systems like grammar rules, like I mentioned before, to be able to further get meaning out of whatever the text or the speech is. NLG, on the other hand, allows the machine to generate text, either by doing something like speech to text or text to speech, which is also reliant on like grammar rules. Yeah, so at a high level, that's what natural language processing is. So if you have more questions, definitely tune into module 4 for that. All right. We talked about computer vision already, but I'll just reiterate that, computer vision allows a machine to process images or videos. So it helps the machine to see, and I say that with quotes, or to understand what's in a digital image, whether that's a video or a still image. So, I make it sound like this is really simple, but it's actually complex, because if you think about the way that people see, or like visual perception in humans, is not that simple either. And there's still a lot to kind of understand with how we see and process information. But just to give you some other kind of successes with computer vision that exist out there today, there's things like medical imaging that, really take advantage of using computer vision. There's fingerprint recognition, or like other biometrics. So, maybe if you use, I know Apple was at some point using the fingerprint to be able to unlock your phone. And, now they also have the ability to unlock using your face. And maybe there are other brands that do that as well. But like those are some of the successes with computer vision, aside from the things that we've already talked about. But when we talk about, but I just want to talk about, if we start to ask questions of, how computer vision might be trying to solve a specific task, we can look at like the application and then see what it's actually doing when we talk about object recognition. So, if I am trying to classify an object in a photograph, what it's actually doing is trying to determine what is that broad category that this object belongs to. So is it a cat or a dog? If I'm doing verification, is the object that I'm looking for actually in the image? If I'm doing identification, what is the type of object? With detection, like if I'm looking for where is the object in the image? For landmarks, what are the key points of the object? For segmentation, what pixels belong to the object? So what part of the image is a tree versus a building? And for recognition, what objects are in the image and where are they? So again, in module 4 in ML Foundations, we'll be doing more of the hands-on work or getting deeper into some of these concepts. All right, and then the last one that I'll talk about, which I think is important because it is used in conjunction, is used a lot today, and maybe you don't recognize it, but is expert systems. So here is what we're simulating the behavior of a human by using expert knowledge. So, this expert system is using relevant knowledge from its knowledge base that's programmed by an expert, and it's going to interpret that knowledge based off of a query from a user. So, the data in that knowledge base it's added by humans. So you can imagine what some of those limitations might be there. But the humans are experts within a specific domain. But it's used by non-experts to get information from it. So this is used sometimes in like medical diagnosis, sometimes gaming and robots. And so, an expert system can take advantage of like the insights that humans have by learning from trial and error. And expert systems are actually very predictable, and they're less likely to make really errors in, an extreme kind of like polar opposite ends when it gets new data that it hasn't seen. But um, you can imagine if it's pre-programmed by an expert, like as more information comes in, an expert has to program it in order for it to be able to kind of like handle something that's new to the domain or whatever. But if expert systems are used alongside like another ML um, approach, then it can help do things like reduce the risk of like those erroneous predictions. And sometimes it's helpful to use more than one system at a time. Are there any questions about anything there? Okay. All right. So now we're going to start to summarize some of the things that we heard, and then we'll talk about what we're going to do in on Thursday session. So just to like do a high level description of what an AI system, um, how to describe what an AI system does. These are some basic things, and they're things that we've talked about, over the last 40 or so minutes. That an AI system should be able to identify new relationships or patterns from the data. It can capture and represent the knowledge that is learned over time. Here, and we'll talk about this one probably in the machine learning in module 3, but we're talking about how to respond with a degree of confidence, because that is important. It continuously learns and reinforces the behavior based off of things like success and failure. And it can be trained by an expert or learned by experience. It can definitely take in large amounts of data if needed. And it can be used to plan a set of actions to reach a goal or to solve problems. Now, this is not an exhaustive list. This is just a summary of, things that an AI system can do. And I say AI system because, like I mentioned before, oftentimes in order to do what we call an intelligent task, you may have to combine a number of different technologies together to be able to get to a quote unquote intelligent kind of decision. But these are largely characteristics of what successful AI can do. Just to finish it up here, these are some examples, and we've talked about them already, but that you might be familiar with. So voice assistants like Alexa, or if you're using Echo, or Siri, they use speech processing to be able to communicate between human and a machine. Maybe use a language translation app like Google Translate or something. That deep learning may be used there to help improve the experience. In the case of music recommendations, so maybe you use Apple Music or Spotify or whatever the other like music sources are. Based on things like based on your listening habits and, other information. So like, what did you search for? How long did you listen? Did you like or dislike the song or album or artist? This information can be used and analyzed so that you get recommended new songs or new artists that, come up. So it's helpful with like discovery of new kind of material. And then, chatbots are really popular because they can help, with efficiencies, in processes, especially, if you're in the customer service business, because a chatbot can be used to provide real-time answers to very specific questions in a dialogue format. So, really, if we talk about this in the context of customer service, the only time, when an escalation is necessary, then that's when a customer service agent will come in and, try to answer any questions. But, commonly asked questions can be, answered by a chatbot. This is just a tip of the iceberg, and there are definitely other applications out there, and there will be new ones, in the future. So hopefully, this prepares you to kind of go into what we're going to talk about over the next couple of weeks. So just to summarize what we talked about, data is really the key to making AI work. Um, Sometimes it's the most important piece aside from the algorithm or the technique that you use. There are a number of different technologies that can be combined to make an AI system. When we talk about AI systems, we're talking about those things that help to um, perform human intelligence related tasks. So, things like perception, pattern recognition, action, taking action, and then learning. And then we also discuss some common use cases of AI technologies. So I'll pause there for questions before I talk about the next sessions and just some next steps. Any other questions? Okay. All right. So the next session on Thursday is going to be titled Solving Problems with AI. And we'll actually be talking about some of the higher level, like branches and that's of AI. So how do we categorize problems in a larger area? And then the next study group will be held on Saturday. And then the Ask Me Anything will be on Sunday. And then we'll start module 3, which is machine learning foundations, on Tuesday, next Tuesday. Just a reminder, I'm not sure how many of you have been able to do your quiz for module 1, but if you haven't, it's not required to move along. But if you do intend to get a badge, probably the closer you are to the session, the more you'll retain that information. But this is just a reminder that, we do have a quiz after the end of a session. You can take advantage of the study groups or the Ask Me Anything to get more information if there's something in it that's not quite gelling with you. But, this is the quiz that is available. And that's it. So if there are no other questions, then we'll adjourn for the day. Let's see. Okay. There's a comment to kind of share any other areas or interesting advances or research in AI, and that's something we can definitely point you to. So by the next session, I can come up with some resources that might be interesting to you. Yes, the session is recorded and it should be up within 2 days, maybe less than that. So yeah, each session should be available within 2 days. And everything will be on the training website. So if you the site that you went to today to access today's session, that will be the same place where you go to see the recording. There's a question here additionally about any examples of AI in agriculture. Yeah, so one of the things that one of the use cases we talked about in the first session, and this is specific to a customer, is Hortifruit, and they deal with blueberry production. So definitely one of the ways that we could apply AI in agriculture is in, predicting things like quality of the produce, predicting whether or not there'll be claims based off of certain information, because claims are expensive, and figuring out how much spoilage there might be, or kind of anticipating who might make a claim could help with saving money. I will say, there are other applications too of using AI in agriculture, and I don't know the exact company, but companies are using like computer vision to be able to spot like ripe fruit. So within the fields itself. I can't remember the name of the company, but if I can find it, I will post that somewhere on the website there. but using computer vision within, like, it's some piece of machinery to be able to pick the ripe fruit and leave the fruit that's not ripe on the vine. Um, those are the major ones that I can think of right now, but definitely, if we have any other examples, we can post those. And the question about resources, they will be updated on the site, and you should have access to the PDF of the document after this session is recorded. So once the recording is posted, you should have access to the PDF. Any other questions? All right. Well, I thank you for joining today. Raphael, did you have any closing words?
No, thank you very much, Chemere, for this, peeling back the onion a little bit more on sort of, demystifying AI. We're going to continue the journey on Thursday, kind of diving deeper. And then I think next week we're going to be starting the introduction into machine learning. So you've probably heard machine learning many times, and Shemere's given some examples of how it can be used, but we're definitely going to dive deeper into that in the next module. So thanks, folks, for joining, and hopefully we'll see you in the next session.